Hello everyone, I am Praful John. This is the video series for Pycaret walkthrough. I'll be going through each of the Pycaret collabs and discussing about the various ML tasks that we can easily do using the Pycaret library. In this video, we'll be leveraging Pycaret to solve a binary classification problem. I will start with an introduction to Pycaret. Pycaret is an open source, low-code machine learning library in Python that automates machine learning workflows. It is an end-to-end machine learning and model management tool that exponentially speeds up the experiment cycle and makes you more productive. In this collab, we'll be tackling binary classification problem, which involves predicting one of two possible outcomes based on input features. So here what we'll be using is the hard data set, which is already provided in the Pycaret library, and we'll be predicting if the person is dead or not. Basically, we'll be predicting the label death. So we'll begin with installation, and we'll be installing all the Pycaret possible versions. And here we can see it's the 3.32 version. And then we'll be fetching the data using the get data function and the available data sets in the Pycaret. That is one of the data set, it's heart, and we'll be performing binary classification on this. So you can see how it looks like, and we'll be basically classifying if the person is dead or not, and this will be labeled to the data. So here what we are trying to do is set up that the target variable will be death, and you have to predict that, and we'll be storing it in the s variable. And then we'll be importing classification experiment, which we are going to use. And this will be used for basically this whole classification experiment, and will be this like this is the class for all standard transformation steps. So we'll be using that, and we'll set up the data for this, and then we'll compare the model and we'll store it in the best. So it will be comparing all of these models from CAD boost classifier to SVM linear kernel, and it will store the best model out of these in the best variable. Here the CAD boost classifier bags the first position and followed by gradient boosting classifier. So then we'll be comparing the models and looking at the what accuracy the different kind of model holds. So CAD boost classifier has an accuracy of 75%, which is pretty great. And then we'll be analyzing the model, and this is the confusion matrix for that. For the purpose, we are using here plot model function, and then we'll classify the model based on the true positive rate and false positive rate on a ROC curve for CAD boost classifier. And then we'll see what are the features and plot them, followed by the evaluation of model. So it is basically showing the workflow, what we are doing. We are doing the data, using the raw data, and then we are using a simple imputer two times and giving it to the CAD boost classifier. Now it's time for prediction, and the predict model function uses prediction label and prediction score to basically define the probability of the predicted predicted class as a new column in the data frame. So when data is none, it uses the test set for scoring. So here we are using the predict model to find the basically the prediction score, and it stores in holdout prediction. The same function works for predicting the label on unseen data sets. So let's try a copy of original data and drop the death table, so we can then use the new data frame without labeling for scoring. So here we are dropping the table, and then we are predicting the model again. and finding the best. Then we're going to save this model in my first pipeline, and it will save the whole model. And this is the detailed function by function overview. So how we use the setup function, and like how we are going to get config. And again, we are trying to compare the model, and out of the best model, we'll select the best one in this best variable. And then we can check what are the available models by calling this models function. So there are many models that are available and which have their unique ID assigned to them. We can also compare tree models, and you can use include and exclude parameter in the compare models to train only selective models, and exclude the specific models from training by passing the model ID in the exclude parameter. So that is what we are doing. And here what it is including is these model, and then it is performing a comparison again. So the models were already prepared. Now we are just trying to basically use the different functions of for binary classification, and try to show how we can basically compare between the different kinds of models, right? Like decision tree classifier or extra trees classifier, random forest classifier, extreme gradient boosting, and so on. That's all for this video. I hope you liked the video, and if you like the video, please hit the like button, and in the next video we'll be discussing the regression problem. Thank you so much for watching.